Lesson 118, finding areas of polygons using matrices. So if you remember, a polygon is, they have to have straight edges. It's a closed figure. So if you knew the points, like on a coordinate plane of the vertices of your polygon, you could find the area of it just using those vertices, as long as you're naming it in order. So the way to find it is, if you have the area equals, you have to find the determinant of the matrix. I thought determinant had straight lines. Okay. So you do, oh no, first I'm going to tell you how to find the determinant of your point matrix. Okay, so determinant of the point matrix. In real life or in math, a determinant is always found with a square matrix. Okay? So when you have a point matrix of more than, this A doesn't mean area. I'm going to rename this. Instead of A, we're going to call it, I don't know, P. That way it doesn't get confused because it's not talking about area. So anyway, when you find determinant, you have to have a square matrix. But when you have a point matrix written in this way, x1, x2, y2, x3, y3, and so on, you're not going to have a square matrix. So technically, you're not supposed to be able to find the determinant. You can always make it a square matrix by adding a bunch of ones. You would just put ones out here and make it square so you could find the determinant. That's a little bit of extra work that you don't have to do if you know that you're just finding the determinant, or you could do it this other way. I don't know, I feel like I'm confusing. Okay, let's say we wanted to find the determinant of P. First of all, we would have to have a square matrix, but we don't. So if you're going to use your calculator and you want to plug it in and find the determinant, because your calculator can do it, just remember that you have to have a square matrix, and you will have one. You'll just have to add ones in. But what we can do is we multiply, it's called the shoelace method. You just multiply this way, across that way. So you would do x sub 1 times y sub 2 plus x sub 2 times y sub 3 plus x sub 3 times y sub 4. Then you're going to keep adding dot dot dot, and the last one you add is x sub m times y sub 1. So the very last x sub m is going to be multiplied with your x sub 1. So one thing I recommend is that you rewrite the top, underneath your matrix, you just rewrite that top line so you remember to end right there. Then you subtract off the product of each term, like each of those going this way. So you multiply them this way. So you're going to do y sub 1 times x sub 2 minus y sub 2 x sub 3 minus y sub 3 x sub 4 minus dot dot dot. Then the last one you subtract would be y sub m times x sub 1. That's the determinant of your point matrix. So I want to give you an example of just finding the determinant of this point matrix. We'll call it B. And the points are 2, 3, 6, 1, and 9, 0. Okay, yes.
What's X and Y's whole?
These are, X and Y 4 would be the fourth point.
So it's the M1?
No, I did dot, dot, dot. So you're gonna have a 4, a 5, a 6, you're gonna go all the way to
It really,
N.
it depends on the polygon.
It just depends on the polygon, yeah. This one, it would be a triangle, right? If we wanted to actually find the determinant, I'd have to add another column of ones to make it. But notice if I have a column of ones, when I go across, I'm just timesing it by 1. So it's not gonna change the value. So that's why we can just do that. Yeah,
So if it's supposed to be a square, why would we just use 1? Because then it's like not even square form, because it just is the same exact answer.
exactly. But in order, like by definition, a determinant can only be found in square matrices. So
Okay.
let's say you wanted to use your calculator to find the determinant, which I can show you at a later date. In fact, I'm gonna put that on my list of things. Okay, so if I did, like, you wanted to plug in your matrix, and then there's a button that says find the determinant of it, so you would just have to have it square. That's, yeah, Andrew.
I'm kind of confused on all the determinant. Is it just like the area?
No, we're not at area yet at all. Determinant is just a single number that you get from a matrix. So,
So you plug all those points in and then you get the determinant?
you have to find it, yeah. Let's see.
The only thing, yeah, because if you look at like the method of computing area of a polygon, the formula, it
It
looks
has-
almost like a determinant is like in a polygon.
It's part of it, yeah.
Yeah, but like, is there a definition to the determinant?
There is, but it's mostly how to find
Can
it.
be negative?
Oh. I don't have it anywhere in here, so we'll have to look that up, what the determinant
This is
actually
very-
means. Yeah.
Dixon had a really good question. Can a determinant be negative?
Yeah. Okay, so we're gonna put, we're gonna rewrite our first row right here, so we don't miss those two. So we're just kind of adding that in. We multiply these ones, and then add them together. Then we're gonna multiply these ones and subtract them off. So we have 2 times 1 plus 6 times 0 plus 9 times 3. Then we're gonna subtract off 3 times 6 and 1 times 9 and 0 times 2. So 2 plus 27 is 29 minus 18,
11?
11, minus 9 is 2. So the determinant of B is equal to 2. Now to find the area of any convex polygon, so this actually only works for convex. Do you remember convex?
Yeah.
Means it's, yeah, there's no parts going inside. So the area of any convex polygon. So A for area equals, you have to do the absolute value of half the determinant of the point matrix. So, you know how the determinant sometimes can be negative. Negative. So if it's negative, you just take half of that in the absolute value, and that would be the area. So if I were to graph these 3 points right here, this triangle, the area would be 1, because it's half the determinant of that, yeah.
Okay. So in the book, in the formula, it says that, so there's the half the determinant times the matrix.
Yeah,
So
that's the point matrix. So you're just finding the determinant of the point matrix. Okay.
Wait, so the determinant of that triangle would be,
The determinant would be 2,
yeah, so just.
but the area would be the absolute value of half of that, so 1. So let's do an example. Yeah.
the one thing I'm a little bit confused about is, so if you were to like multiply 1/2, oh, So 1/2 times 2 is 1. And then if you times that by the matrix, it would just be like, it would be the same matrix.
Wait, what?
Because, so you're multiplying the detriment times half times matrix.
No, I'm not timesing it, but, no. That, DET in your formula in the book is saying the determinant of that matrix. You're just finding that number.
Okay.
So that's what we did here. The determinant of matrix B, the determinant of the matrix. You're not timesing or anything. You're just
Oh.
finding that number, that one number.
Okay, that makes way more sense.
Okay. And B 6, 2, and C -1, -4. So we're going to make the point matrix. We're going to find half the area. Now when I have straight lines, oh, that's just the absolute value. Half the determinant of this matrix. So I make this point matrix 0, 4, 6, 2, -1, -4. This is a different way than we've written point matrix before. Usually you do X, Y. You only have 2 rows of all your points. But this one you put them in columns. And then in real life, in real math, you'd add a column of 1s, but we're not going to do that. So we'll just do the shoelace method, and we're going to take 1/2. That's going to be the absolute value. And then we're going to rewrite this top row right here. We're going to multiply these and add them together. So we have 0 plus -24 plus -4. Then we're going to subtract these products. So 24 minus -2 minus 0. So let's see, we have half, the absolute value of half times, we have -24 minus 4 is -28 minus 24 plus 2. So we have -28 minus 24 is -52 plus 2 is -50. So the absolute value of half of -50 would just be 25. So the area would be 25 units
What is
squared.
negative 1 time?
And that's the end of the lesson.